This is Dr. Jeffrey Dick. I'm the chair of the Department of Geological and Environmental Sciences at Youngstown State University. And I'm a geologist, and mainly the things that I get involved in are things related to oil and gas. Specialty in groundwater and surface water is very important to not just Ohio, but any place on Earth, because water is our most important natural resource next to the air that we breathe. And so it's very important that we understand our water, where it comes from, how we use it, how it can be misused, and that's a very important aspect of geology. Now, many people think my other area of expertise, oil and gas, doesn't go along with water quality, and in fact it does, because the oil and gas industry uses a tremendous amount of water, as do many other industries. And so it's very important that we keep an eye on our water resources and understand how water is used and misused.
Has the oil and gas industry had a negative effect on the water here?
In the state of Ohio and Pennsylvania, for that matter, and you could throw West Virginia in with it, there has not been a negative effect on the water from the standpoint of overall in the amount of water that we have, the quality of the water. With any industry, there's going to be some risks that come with it. So occasionally some water may be tainted by a small spill or something of that nature. But by and large, in Ohio, the recent oil and gas activity, that is the Utica Shale and the Marcellus Shale, they've had very little impact on the water here in the state. I've been a shale guy in many ways. When I was working on my dissertation for my doctoral degree, I studied the weathering of shales and how that relates to landslides and slope stability problems. So I've known a lot about shales for quite a while, but yeah, they're interesting. They're the most common type of sedimentary rock on planet Earth, so we have lots of them. And I've worked in the oil industry over the years. My first major career was working as a petroleum geologist for Chevron, offshore Gulf of Mexico. That was back in the 1980s. And after that, when I came back to Ohio, I worked for a small independent company doing pretty much consulting work, advising work to them. And yeah, oil and gas has always been of interest to me, but it's really in about 2007, it really piqued my interest when the Marcellus Shale in Pennsylvania was being explored and drilled. And I was aware that here in Ohio we have the potential for the same thing, and wondered when it might come to Ohio. And 2010 is really when it started here, and really started taking off in 2011, getting into 2012. And here we are today with a whole new industry that's really changing the economic landscape for Eastern Ohio and creating a lot of great jobs in the process. I got involved in geology without knowing it at a very early age. I always loved hiking and camping and collecting rocks and doing all the outdoor type things. I was just an outdoor person. And when I went to college, I didn't know I wanted to be a geologist. I actually started as an architecture major, but took a geology elective course, a physical geology class, and loved it, and realized that geology is really what I wanted to do. And so I changed my course and never turned back, and have never regretted it. Why people should be interested in geology? That's a good question, and it's one that I often think about. And there's a multitude of reasons. Number one, geologists study the earth. A lot of people just think we study rocks, but we don't. We study the earth, how it formed, how it's changed over time, what's likely to happen in the future. And since we're all residents of the planet Earth, we should have an interest in how our Earth operates and where it's been and then when it comes to our resources. Geology probably would not exist as a science if it wasn't for the dependence of humans on the natural resources that we extract from the Earth so that we can go about our daily lives. Virtually everything that you see around you in this room, and one could argue that even the wood that this table we're sitting at comes from the earth, but that was once a living plant material. But most of what you see, the steel and the doors and the structure, the glass and the lights, the energy that makes the lights work, all of that comes out of the earth. And so it's very important that we understand The geology is more than just studying the earth, but it's also providing natural resources for humankind and how to use them wisely. The way things tend to go is that as resources become more scarce, we tend to use them more wisely. And geology's not to blame for that. That's human nature is to be blamed for that. And so I wish things were different. I wish that we had conservation in mind from day one whenever we're looking at a natural resource, but often that's not the way it works. It's not until you see the well running dry, so to speak, that you really value the water. And so that applies to all areas of geology and mineral resource development. Many geologists today that come through our program study geology and become geologists, professional geologists. They end up working in environmental related fields of geology, which can be related to the oil and gas industry, mineral mining, down to actually cleaning up environmental disasters that have really nothing to do with geology but have more to do with industry. And so there's an awful lot of applications for geology today and for environmental sciences. Yeah, I would say that if you're interested in the earth, if you're interested in the environment, protecting the environment, or interested in conserving our natural resources but maintaining resources that can sustain our life on the planet, consider geology as a discipline that you'd study in college, or environmental science that you might study in college, because these two fields are going to be key down the road to solving many of the problems that we've talked about here. I'll give you the short on the shale gas thing. For 40 or 50 years at least, geologists and petroleum engineers have known that there's large reserves of oil and gas locked up inside of shale formations. It wasn't until the late 90s, early 2000s that a company out of Texas, first Mitchell Energy and then Devon Energy, were able to figure out how to extract oil and gas from shale. And that started with the Barnett Shale in Texas. And since that point in time, there have been no less than about a dozen different shale plays explored and developed across the United States. Here in Ohio, the Utica Shale is the big one, but if you go over into Pennsylvania and West Virginia, the Marcellus is the big one. And so basically, we're at a point in our energy development in this country and around the world for that matter, that most of the easy oil to find, the old traditional oil that comes out of sands and limestone formations, has been found, and the production in the United States has been declining for many, many years. With the advent of shale gas, we're able to extract oil and gas directly from the shale, and as a result, the United States oil and gas production is rapidly increasing. And so for the first time in a very long time, we can look ahead to the future and see the possibility of the United States being energy independent. And so the whole idea with shale, the way it works, is that you don't just drill a traditional vertical well like many wells of the past, and many wells of the past were vertical and hydraulically fractured. But with shale gas, you drill the well vertically, you get down to the shale formation that you're interested in, let's say the Utica Shale, and you turn the borehole so it runs horizontally, and you run down the length of the shale formation for a distance of 4,000, 7,000, 9,000, even 11,000 feet. And then that part is hydraulically fractured, and through those long horizontals, we get significant production of energy. So with shale drilling, what makes it different from traditional drilling of the past? And it's important also to interject that Ohio has had oil and gas industry dating back to 1860. And at the turn of the 18th century, going into the 1900s, the largest oil field in the world was here in Ohio. And so we have a very long and rich oil and gas history here in Ohio. The shale gas, the Utica Shale, is something new, and it's proving to be very good for the state of Ohio from the standpoint of economic development, job creation, energy development, things of that nature. And so here in Ohio, the Utica Shale started development in 2010, and really late 2010, and so here we are a good 3 years into it, and at this point in time there's been over 700 wells drilled, and about 300 of those wells are producing today.
Where the other 400 go?
Well, the other 400, they're drilled, but they're waiting for pipeline hookups
Oh,
so that they can start producing them and actually drill more wells. So what happens in the oil and gas industry is, in a new area that hasn't been drilled before, like the Utica Shale, they'll come in and drill wells in various places, trying to find the best places to produce from. And in the process, they drill a lot of holes, and then they can't produce anything from those holes until there's pipeline infrastructure in place and processing plants. And that pipeline infrastructure and processing plants, that's going on right now in Ohio in a very big way. And so as 2014 unfolds, we'll see most of those wells that have been drilled will be producing. I expect by the end of 2014 we'll have 800, perhaps 900 wells in production in the Utica Shale here in Ohio.
well, our internet question goes into this. Hey Baylor asks, do you believe fracking is a leading cause of the recent increase in earthquakes?
There is a common message from the news media, both the printed, like newspapers, and television and radio, that very quickly jumps to the conclusion that if there is hydraulic fracturing or shale gas drilling activity in an area that also experiences an earthquake, that the shale gas activity is the cause or the event that triggered the earthquake. The truth of the matter is that we can't jump to conclusions like this. Instead, what we really need to do is study these things, better understand them. And here in Ohio, we're in pretty good shape because the Department of Natural Resources has deployed seismographs to areas of interest where either shale drilling is going on or what we call deep well injection, class 2 injection, where you take drilling fluid, saltwater, brine, flowback materials, and you inject them deep into the earth. There was an earthquake event here in Youngstown on New Year's Eve of 2011 that did lead to triggering of an earthquake here in the Youngstown area. And up to that event, there were several other earthquakes that had occurred. And so there is a distinct possibility that at least injection activities can trigger earthquakes. But that is, when you consider that there's more than 30,000 injection wells operating in the United States of America, and the number of injection wells that are associated with earthquake activity amounts to about 8 of those. And of those 8, probably 3 of them have some pretty good evidence suggesting that, yes, indeed, the injection activities cause earthquakes. Then there is a reason for concern. And so I would say that when it comes to injection activities, we have to be very careful that the wells that are injecting the fluids are not close to active faults. So when it comes to shale gas activity and earthquakes, one of the things that we have to be concerned about is injection wells, are they close to faults? Or in the case of a drilling of an unconventional shale gas well that's undergoing hydraulic fracturing operations, is that well intercepting an active fault? And if that's the case, we have to be careful about it. Now, there were some recent earthquakes here in Youngstown in the past week that are in close proximity to where there is some shale gas drilling activity going on. And the wise thing to do at this point in time, rather than panicking and getting upset about it, is to allow the Department of Natural Resources to move forward in their investigation, of which the first step was to shut down the oil and gas drilling operations at that location. And then the next step will be to gather up scientific information that can allow us to determine if indeed this particular shale gas drilling operation is somehow triggering earthquake activity. And that's the proper way to go about things. Oh, no, there should be concern, and there are some very legitimate concerns. When it comes to shale gas development, in order to what we call hydraulically fracture the well, which has become known as fracking, in order to hydraulically fracture the well, we use enormous quantities of water. So anywhere from 4 million to 10, perhaps even 12 million gallons of well in the hydraulic fracking operation. Now you have to put that in perspective, because when you say 5 million gallons of water, people just picture an immense amount of water. But the truth of the matter is if you went and stood along the Ohio River as the water's flowing by in the Ohio River, in the course of about 1 second, you'd have about 5 million gallons passing by you. The amount of rainfall that comes in a typical rainstorm, maybe a half of an inch of rain over an area of a couple of counties, would amount to hundreds of millions of gallons of water. And so it's important to keep it in perspective. What the real concern to me is that the water that we use for hydraulic fracturing, we remove it from the surface where it's available to use by humans, other living organisms, whatever it might be on the surface of the earth, and through hydraulic fracturing and then disposal of water that flows back out of the wells as produced water or as flowback. Much of that is put back into the earth in injection wells, where it'll ideally stay down there for eternity. And so we're removing water from the water cycle in the process. Now that's not really a problem in Ohio, because we have abundant water supply here in Ohio, but in more arid areas it'd be very wise to look at ways to conserve that water. And indeed, the industry and science and the government are all sponsoring research to do just that. And so it's my expectation that in the next 5 to 10 years that we will see less and less of wastewater being put in injection wells and more of it being recycled or purified through evaporation or reverse osmosis or whatever process may come next, and really cut down on the water use. Some of the most magnificent volcanic features that we have in the world are right here in the United States of America, in and around Yellowstone National Park. And there's evidence, widely spread evidence, that in the past, the volcanic activity that leads to the hot springs, the geysers, the mud pots, all the other things that we associate with Yellowstone National Park, that there's a lot of evidence to suggest that there have been some really big volcanic eruptions. And when I say really big, compared to eruptions that we might, like Mount St. Helens, for example, or Mount Pinatubo, Vesuvius, things like that, those all are newsworthy. I mean, they're happening, in recent history, and so they impact us, but none of them hold a candle to the size of the volcanic activity that is associated with Yellowstone. So in that sense, since it's still an active volcanic area, there's still plenty of heat, a heat source below the surface, it's quite likely that some point in the future we'll see another super volcanic type eruption. When that would happen, nobody can really say, but I don't think anybody's speculating that's going to happen in the near future. But there are scientists studying it and looking at things like heat flow measurements and changes in the tilt of the Earth's surface as volcanic materials move below the surface. As they move upward, they can cause the surface to swell. And they'd be things that a human, if you went to the same place and observed your surroundings year after year, you probably wouldn't notice a difference. But if you put delicate scientific instruments in place, you can measure very small differences. And those, along with the rumblings of lava underground that cause minor earthquakes, they all tell us things. But it's very hard, extremely hard to predict volcanic eruptions when they're going to take place. So the best we can do is just enjoy life and figure that someday something might happen, and so be it. There's a very easy way to avoid a super volcano or the consequences of a regular volcano, and that is don't build cities and societies around active volcanoes. But since many of our active volcanoes are along coastal areas and world population is concentrated in coastal areas, and a lot of the world population, particularly when you think of Indonesia up through Japan, New Zealand, a very active volcanic area, those islands are all volcanic islands and highly populated. So you can't say at this point in human evolution and how we've inhabited the earth to change those practices. So kind of sitting ducks if you live near a volcano. Probably most everybody, 99.99% of everybody's going to be safe, but people do perish when there is a volcanic eruption, and right now in the United States, particularly the Pacific Northwest, I'm thinking of Seattle and Portland, Oregon, are very close to active volcanoes. And so the reality is there that someday there might be a massive eruption that makes Mount St. Helens look tiny, and there might be the unfortunate consequence of a lot of loss of human life. But in the case of the supervolcano with Yellowstone, the good thing about it is it's a national park in a very sparsely populated area, and so it may not impact that many people. But
the ash is going to travel, though.
the volcanic ash will travel, and people will have fun playing in it. Here in Ohio, who knows, maybe we might get a couple inches of it piling up on the ground. But the closer, and that's just speculation on my part, it might be more than that. But as you get closer to the Yellowstone, you would expect the volcanic ash to increase the thickness, the amount of it falling out of the sky. One thing that has been observed over and over again in fairly large volcanic eruptions, Mount Pinatubo was a good one, and then the unpronounceable volcano in Iceland that interrupted all sorts of transatlantic air travel. There is well documented evidence from volcanoes of that type that the volcanic dust in the atmosphere can actually cause sunlight to be reflected away from the earth and not as much penetrating the atmosphere, and it can cause a cooling down of the earth. I think back during the Cold War era they talked about a nuclear winter, and it would be something similar to that, but instead of human-induced nuclear bombs putting dust up into the atmosphere, it would be of a natural source of volcanic eruptions. And so the important thing to realize is that volcanoes are a natural part of the earth and our environment, and so if they cause short-term or long-term weather, climate change, that's all a natural process, and it's us as humans that are very good at adapting to changes in our environment to adapt to the changes that would come with that, if it happened.
Do you think we can?
Absolutely. What makes humans so dangerous to the rest of the animal and plant life on planet Earth is that we have this incredible ability to create environments around us rather than having to adapt to environments that are presented to us. So we're not like a primitive sea creature that if sea levels were to change, either go up or go down, the only thing they can do is move with the water, whether it be inland or further out to sea. And for us, our cities along the shorelines, you can bet that if sea levels start rising, we'll build walls to protect them and pump systems to pump the water out. And beach homes will still be there, but we'll move them inland a little bit, or we'll put them up on stilts. We'll do something. So humans have always been able to adapt to their environment and create conditions that make the environment suitable to them. And that's not going to change. I don't really know enough about the Yellowstone supervolcano to say what a safe distance would be, but given the historical record of the volcanic ash that's piled up from past eruptions, I would say that if you're within, let's say, I'm just throwing a number out there, I might be way off, but if you're within a couple 100 miles of the volcano at the time that it erupts, you might have a very large amount of ash coming down, and if you try to take shelter inside your home, it could cause the roof of your home to collapse and things of that nature. Probably the best thing you could do during an eruption of that nature would be to hop in your car and hightail it out of town and just head away from it as fast as you can.
But your car's engine won't run very long after sucking in the...
Yeah, that's very true. So you don't want to be sucking in the volcanic ash. But I would suspect that with an eruption of that type, the volcanic ash is going to go very high into the atmosphere, and it's not going to settle immediately. So I don't know. I'm just looking at if I lived within a couple 100 miles and it erupted, I would get out of Dodge. That's how I'd approach it, and I'd deal with my car choking and dying down the road as a consequence of my decision to hightail it out of town. But I'd probably be better off than sticking close to the source. And the other side of me would want to get closer to it and see what was actually happening.
Have you actually seen a volcano eruption up close?
No. I've hiked on Mount St. Helens, after the 1980 eruption. But in Mount St. Helens is an all by all means an active volcano, but no, I haven't been around an active volcanic eruption. Just seen lots of videos and pictures from family members that have been to Hawaii, and I'm a geologist and I haven't been there yet, but it's on my bucket list. I'll get it. I'll get there someday. I would say the way that we have utilized energy as a global civilization started out with good intentions, first burning wood, and then finding coal and burning that, and then finding the ultimate fossil fuel, which is oil, and using that. That all is logical and it follows good reason why we did that. But at the same time realizing, and we've known this for very many years, that oil and gas and coal, to a lesser extent, is a limited resource, and that by using these fossil fuels, combusting them to create energy, we create a lot of carbon dioxide and carbon monoxide, but carbon dioxide is primarily one of the downsides to it. So we've taken carbon that has been stored in the earth over millions and millions and millions of years, and we're extracting it and combusting it and putting it back into the atmosphere in a matter of hundreds and hundreds of years. And so I would say that our utilization of energy started out making sense, but somewhere along the line we really should have started looking at renewable sources in a much more serious way. And to this very day, we don't look at renewable sources in a serious way. It's talked about, but to this day, we don't have any government policies in this country. We don't have an energy policy to this date. And it would be really nice that back in the 1970s, when a lot of this started coming to light, that we did like a man on the moon type mission, but dedicated towards perfecting solar energy, and the secondary form of solar energy would be wind energy. And we've done a miserable job on that. And so if we'd started in the 1970s, I'm pretty confident that 40 years later, where we are right now, that we would have advanced our ability to capture solar radiation, which is the external energy for planet Earth. That's the biggest source of energy out there. And you can feel it on your skin even on a day like today when it's kind of cool outside, but the sun comes out from behind a cloud and you feel it immediately. So it really makes sense. So that's probably, in my way of looking at things, probably the worst that humans have done. Well, maybe not the worst. The second worst. I have a mental train of thought. Probably the worst thing humans have done is had uncontrolled population growth, because the Earth is stretched to its limits on what it can handle as far as population, getting food to feed all these people. We see it in the forms of our marine life being diminished, and we really need to control population on this planet, not just in our country but around the world. So maybe that's the worst, and then energy is the second worst. As far as the best, I think humans' ability to our brains that we have between our ears give us this immense ability to develop new technologies and come up with things that right now there will be things invented 10 years from now that nobody could even imagine, or maybe somebody sitting in a garage or in a basement or a laboratory has an idea, a thought in their mind, and we can't really see how it's going to manifest itself. And communications is probably the best example of that we have today. And what immediately comes to mind when you talk about sinkholes, and the recent ones that formed down in Bowling Green, Kentucky, where the National Corvette Museum lost some really nice cars down into a sinkhole. And in that situation, what you're looking at is limestone, which that area, if you're not familiar with it, is where Mammoth Cave is also found, National Park. And so the area is very famous for underground caverns. And in those areas, and you find it in Florida as well, those caverns can work their way up towards the surface, and unknowing to people up on the surface, they're not aware that it's there, and they can be surprised by a sinkhole. Now, in the case of oil and gas development, extraction of oil and gas out of the ground, it's not going to lead to the formation of sinkholes, and for a couple of reasons. Number one is you're taking the oil and gas out of tiny little pore spaces between mineral grains in sedimentary rocks, and although you can cause some compression of the rock, because most oil and gas formations these days are relatively deep, if there was any settling because of that extraction, it would probably be measured in micromillimeters. It would be very, very small, imperceptible. We wouldn't even realize that it's happening. Yes, I do have a favorite rock, and I actually have a couple of them, but of my all-time favorite rock is a rock called migmatite. And I'm a sedimentary rock guy for the most part, and a migmatite is a rock that's half igneous and half metamorphic. And it's perhaps one of the most beautiful rocks there is, and I became very attached to this particular type of rock when I was on a fishing trip in Canada and stepped out of the canoe, and there I am, and I'm standing on a rock getting ready to get up on the shoreline, and I look down at my feet and I see this rock, and it's got mossy stuff and algae growing on it, but through all the algae I thought, wow, there's some interesting patterns in this rock. And so I took the rock and brought it back, cut it on a rock saw, and to this very day it sits in my office, and it's one of my absolute favorite rocks of all time.
Cool.
My second favorite rock, which would be the close toss-up, would be granite pegmatite. And I also find those in Canada where I go fishing, offshoot of the gold mining or the gold prospecting that they did in the 1800s up there.